Good day, everyone. I'm Evan Pateño together with my partner, Mr. Joric Labrador. And now we will be solving a problem using some codes that will tackle about the dining philosopher problem. So why is the dining philosopher became a problem? It's because it doesn't have a proper sequence of the occurrence, which the primary concern is the problem of synchronization. So the dining philosopher problem is focuses on the five philosophers sharing a round table, which the three states of the philosopher are presented, and these are the thinking, hunger, and eating states, where each of them has a bowl of food, and together with the five forks that we can find between each pair of philosopher. So the question or the real question is, how can we give an algorithm in order to avoid or eradicate the issue of hunger or starvation. So my partner now will design a discipline of behavior or a concurrent algorithm such that no philosopher will experience starvation, and each of them forever continue to alternate between eating and thinking without minding of the issue or concern about hunger. And of course, if the deadlock will occur. So let's find out and let's go.
Hello everyone, I am Jorek A. Labrador Jr. and I will be showing you the algorithm of this problem, the dining philosopher problem. But first, let's talk more about this problem. The dining philosopher problem states that a number of philosophers, for here in our example there are 5 philosophers, that is seated around a circular table with one chopstick between each pair of philosophers. There is one chopstick between each philosopher. A philosopher may eat if he can pick up the two chopsticks adjacent to him. One chopstick may be picked up by any one of its adjacent followers, but not both. So to solve this problem, we have to use the semaphore solution to the dining philosopher. So each philosopher is represented by the following pseudocode. So here we have the pseudocode, the process P indicated here is the philosopher, and the open bracket I close bracket is an array. So the first philosopher, while true, do think, then pick up the chopstick 1, and chopstick 1 plus 1 in mode 2, that will be equals to 2. So he pick up chopstick 1 and chopstick 2, and then that philosopher will eat, and after done eating he will put down the chopstick 1 and chopstick 2. So as my partner Mr. Pateño stated, there are 3 states of philosopher: the thinking, hungry, and eating. So we will be now showing you the algorithm or the code for this particular problem. So here is our code. So as you can see, here there are 2 semaphores, the mutex and the semaphore array for the philosophers. So mutex is used such that no 2 philosophers may be able to pick up or put down at the same time. The array is used to control the behavior of each philosopher, but semaphores can maybe result in a deadlock due to programming errors. So we have to be careful with that. So here we have the test function and the take fork function and the put fork function and the philosopher, and here is our main. So let's see this let's see this program in action. So first we have to compile it. There's no errors or warning, so it's a success. Let's run this code now. Now let's pause this for a minute. So the first thing we'll do that the 5 philosopher will be in the state of thinking first. So philosopher 1 is thinking, philosopher 2 is thinking, philosopher 3 is thinking, philosopher 4 is thinking, and finally our philosopher 5 is thinking. Now philosopher 5 is hungry. Also philosopher 4, 3, 2, 1 is hungry. All of them are hungry. So the first one will be to take the fork is the philosopher 1. So he takes fork 5 and 1. And he is now eating. And he will put that fork 5 and 1 down. Now he is thinking again. So philosopher 5 takes 4 and 5 because the chopstick that the philosopher 1 had, the fork 5 will now be able to use for the philosopher 5. So he is now eating, and while philosopher 5 is eating, philosopher 2 takes fork 1 and 2. So philosopher 2 is eating. In this situation, we have philosopher 5 is eating and philosopher 2 is eating. So while philosopher 2 is eating, philosopher 5 is putting fork 4 and 5 down. So philosopher 5 is thinking. So while philosopher 5 is thinking, philosopher 4 takes fork 3 and 4 because the fork number 4 is now available because philosopher 5 is now thinking. So philosopher 4 is eating, and while philosopher 4 is eating, philosopher 2 from before is now putting the fork 1 and 2 down. So he is thinking. While philosopher 2 is thinking, while philosopher 4 is eating, philosopher 1 is hungry. Now he takes 5 and 1 because the fork 5 and 1 is available, as philosopher 2 is now putting the fork 1 and 2 while the state of philosopher 2 is now thinking. So philosopher 1 is eating, and so on. We will continue this program. So this is the algorithm of the philosopher dining philosopher problem. Thank you for watching.